Welcome to AI Peer Review, where we unpack complex AI research and extract the most important insights for you. Today, we're diving into an incredibly timely and really interesting paper, the Kwai Keye-VL technical report from the key team at Kwai Group.
Yeah, it's a great one. It tackles a problem you definitely see daily, the explosion of short-form videos.
Mm.
TikTok, Reels, they're everywhere. But for current multimodal large language models, MLLMs, really getting what's happening in them, that's been a huge challenge. They often miss the flow, the timing, the nuance.
Exactly. And that's where Kwai Keye-VL is trying to make a real difference. The core mission, as I see it, is bridging that gap in video understanding, making these models truly fluent in dynamic visuals, while importantly, keeping their general vision language skills sharp. It's about more than static images, it's about the whole story in motion.
And what's really fascinating is how they're going about it. The paper outlines two main pillars, essentially. First, this just massive data set, over 600 billion tokens, with a serious focus on video. But it's not just big, it's meticulously engineered for quality. And second, this innovative multi-stage training recipe, including something they call a 5-mode cold start process, which sounds complex, but the idea is it teaches the model not just what to reason about, but crucially, when and how, like developing a kind of metacognition.
Okay, that does sound like a fundamental shift. So for this deep dive, we'll first, peel back the layers of Keye-VL's architecture. Then we'll explore how they built that huge data set. We'll definitely get into the training methodology, especially that cold start thing, and of course the results. And finally, we'll put it through our own peer review, look at the arguments, the methods, the significance. Sound good?
Sounds great. Let's jump in.
All right, so let's start by looking under the hood at the Kwai Keye-VL model itself. At its core, yeah, it's a classic MLLM structure. Vision transformer, MLP projector, language decoder. Pretty standard stuff there. But they've made some clever tweaks, particularly for video.
Right. One key thing with the vision encoder is what they call native dynamic resolution. Instead of forcing images into a fixed size, it handles them at their original resolution. Think of it like preserving all the detail, whether it is a tiny object or a wide shot. Super important for complex video frames.
And to understand the space within those high-res images, they use 2D rotary position embedding, ROE, which apparently helps it extrapolate better, meaning it can handle details effectively even in really large images.
Exactly. And building on that, their encoding strategy is really flexible. It dynamically assigns visual tokens, whether it's a still image or video frames. It can handle a lot of visual information, up to 116.384 tokens for an image, and dynamically adjusting for video frames up to maybe 200 and 476 total vision tokens. And here's the really neat part for video. 3D ROPE. This isn't just about knowing that time passes. It creates a direct link between the position encoding and real-world time, like +1 position equals plus +0.5 seconds. So the model gets this precise internal clock for understanding temporal progression and event timing.
Okay. That deep temporal sense sounds like a potential game changer for video.
Okay.
Okay, so architecture's smart. But a model is only as good as its data, right? And Keye-VL's pre-training data set is, well, huge. Over 600 billion tokens, public sources, their own internal stuff, and a heavy focus on high-quality video.
Absolutely. And the meticulous data engineering is key here. They didn't just scrape data, they filtered it rigorously,
Yeah.
using things like CLIP scores, even other MLLMs to judge quality. They also talk about image-based deduplication, using FASH and MinHash, basically fingerprinting the data to avoid training on benchmark samples, which is critical for fair evaluation, preventing leakage. This kind of data hygiene, it's so important but often overlooked.
Right. So with this massive clean data set, what did they feed it? Well, for image captions, they didn't just use existing ones. They actually recaptioned lower quality open source data using really powerful models like Qwen 2.5 VL and GPT-4o to get richer, more accurate descriptions, like having an AI tutor refine the learning material.
Yeah, that's clever. And for OCR and visual question answering, especially for Chinese, they use synthesis techniques, like generating varied questions automatically and rendering text in different fonts to make the OCR more robust to real-world variations.
Makes sense. They also included grounding and counting data points, boxes, polygons, so the model knows where things are, and interleaved text-image data, like from PDFs or STEM papers, which helps with longer-range reasoning across both text and images, understanding context that spans modalities.
And then, of course, the video data. Being Kwai, they obviously focused heavily on short-form video understanding. They built pipelines for integrating audio transcription via ASR, recaptioning videos at different frame rates, adding frame-level OCR. But what really stands out are the reasoning-enhanced tasks, things like frame-level reordering or multiple video matching. These teach the model the temporal and semantic links. It's about understanding the story, not just the objects.
Okay, that's deep. So with all that data, they used a 4-stage pre-training recipe. Sounds quite structured. Stage 0 is VIT pre-training, then stage 1 alignment, stage 2 multitask pre-training, stage 3 annealing, like a carefully planned curriculum. You can see this in figure 3 of the paper.
Exactly. And one interesting final touch they mentioned is model merging. In that last annealing stage, they averaged weights from models trained with slightly different data mixes, sort of like getting multiple opinions to form a more balanced view. Helps reduce bias, makes it more robust overall.
Okay, so that's pre-training. Now, post-training. They called this the path to advanced reasoning. 2 phases, 5 steps, and again, rigorous data deduplication. They seem really serious about clean evaluation.
They are. Phase 1 is no reasoning training, basically building a strong foundation. This involves supervised fine-tuning, SFT, using their proprietary Task Galaxy framework, like 70,000 multimodal task types. Huge variety. They even used MLMs to generate tougher data points here, sort of guiding the initial learning.
And after SFT, they do mixed preference optimization, MPO, using diverse data sets, including what they call reinforcement fine-tuning or RFT data. This RFT data is designed specifically to hit the SFT model's weak spots, identified through benchmarks and human feedback. It's like targeted practice.
Right. But phase 2, reasoning training, is where, as they put it, the core breakthrough happens. This is about cultivating real understanding, not just pattern matching.
It kicks off with step 2.1, Coat Cold Start. This uses that 5-mode data mixture you mentioned. Conventional Q&A, sure, but also long chain of thought, auto-reasoning decision data. Think with an image data like generating code to analyze an image and high-quality video data. The key idea here is teaching the model to decide when and how to reason. It's metacognition for AI.
Exactly. Think about their strawberry counting example in Figure 11. The model writes Python code to crop and zoom the image to count better. That's the think with image part, using tools like a person would. Then there's the auto-think mode, shown in Figures 12 and 13. The model learns to gauge complexity. For a tough geometry problem, Figure 13, it outputs its thinking steps. For something simpler, like a Pythagorean theorem lookup, Figure 12, it just gives the answer. It avoids overthinking, which is pretty efficient.
Smart efficiency, yeah. Then, step 2.2 is mix mode RL, using an algorithm called GRPO with reward signals from other MLLMs. These rewards score not just correctness, but also the consistency of the reasoning. This helps nail down multimodal perception reasoning, especially for short video.
And the final step, 2.3, is iterative alignment. They use rejection sampling and a hybrid scoring system, rule-based for things like repetition, model-based for cognitive quality. It's like a feedback loop to fix logical flaws, repetitive outputs, and fine-tune its ability to judge problem complexity, constantly refining.
Wow. That is a complex training process, and doing all this with billions of parameters, it needs serious compute. They mentioned using hybrid parallelism, dynamic load balancing, stuff like that. Those engineering details are crucial for making these ambitious training plans actually work at scale, especially with video data being so heavy.
Absolutely. The infrastructure enables the AI breakthroughs.
Okay, so the architecture is smart, the training is incredibly sophisticated, but does it actually work? Let's talk evaluation. On general vision language tasks, Keye-VL seems pretty strong. Competitive performance, often hitting state-of-the-art or close, especially compared to similar-sized models. Figure 1 shows this nicely on a radar chart.
That's right. Good scores on things like MMM-UVL, 71.4%, and AI2D, 86.7%, according to Table 3. And importantly, a lower hallucination rate on Hallucion Bench, 67%. Hallucination is often the Achilles heel, so that's good to see. But where it really stands out, as you expect, is video.
Totally. They report an absolute improvement of 8.7% on video MMMU when it's in thinking mode. That's significant. And what's fascinating is how the auto-think mode sometimes beats the explicit thinking mode, like on long video bench, by about 2%. Suggests maybe it's already captured enough from the input, doesn't always need the full reasoning chain. Efficient understanding.
Yeah, that efficiency point is interesting. And beyond public benchmarks, they contributed the KCMM bench, the Kwai community multimodal benchmark. It's open source, focused on real-world short videos, fills a real gap. And on this benchmark, Table 4, Keye-VL scored 68.03% accuracy on average. The next best was way down at 57.62%. That's a massive lead for real-world scenarios.
Huge difference, yeah. Really shows the value of their video focus. Now, what about their internal benchmarks and human evils? These often give a deeper picture. They argue public benchmarks have contamination, English only, not enough real-world tasks, especially for short video platforms, monotonous difficulty.
Right, so their internal benchmark was designed to fix that. Focused on native Chinese, open-ended Q&A, used a detailed capability taxonomy, Table 10. They stress using authentic, diverse data and really thorough contamination checks like timestamp verification, manual checks. Very rigorous.
And the human evaluation protocol sounds solid, too. 3 independent annotators scoring across 5 dimensions: correctness, relevance, comprehensiveness, fluency, creativity. With a strict rule, if any single dimension scores below 3, the overall score is capped. Prevents hiding weaknesses.
And the results? Pretty impressive. On the video subset, Table 5, Keye-VL 8B got the top overall score, 3.33, scoring really high on comprehensiveness, 4.36, and creativity, 3.75. Shows it gets the complex narratives in videos. On images, Table 6, it also led 3.81 overall, strong on correctness, 4.05, and comprehensiveness, 4.49. Interestingly, lower creativity on images. They argue this is because it's training really honed dynamic relational reasoning from video, not static image creativity, kind of specialized.
That specialization makes sense. And the fine-grained capabilities. Clear strengths in video for visual element recognition, 3.89. Prior knowledge QA, 2.78. Robustness, 3.50. And its lead in multi-image analysis, 3.5, even on image tasks, is interesting. They think that comes from understanding multi-frame correlations learned from video, so video skills transferring over.
Yeah, that transfer is cool. And the case studies in Appendix C give you a real feel for it, like figuring out movie names from just emojis. Figure 6, pure text reasoning. For images, there's a subway map puzzle, Figure 7, where it shows reflective ability, like checking its own work. And identifying product attributes in e-commerce, Figure 8, practical stuff.
But yeah, the video cases are maybe the most striking. Understanding subtle comments on short videos, Figure 9, like getting the humor. And solving complex physics problems just by watching a video, Figure 10, breaking down the steps. That shows a really sophisticated grasp of dynamic visuals.
Definitely demonstrates advanced understanding.
Okay, let's shift to our critical peer review then. First up, argument and evidence. How well do they back up their claims? I'd say the claims about short video performance are exceptionally well supported.
I agree completely. The evidence from both public benchmarks, like Video MMMU and their own KCMM bench, is really robust. They do a good job connecting their specific methods, the training stages, the data engineering, directly to the performance gains they show. The quantitative results, those percentage improvements, add a lot of weight.
The only slight nuance, maybe, is that direct comparisons with some big closed-source models like GPT-4o or Claude 3.7 aren't across every single benchmark, which is understandable given those models aren't fully open, but it's just something to note if you're looking for exhaustive comparisons everywhere.
True. Now, clarity and structure. I thought the paper was excellent here. Very logical, flow intro, architecture, data, training, evaluation, clear sections. And the figures really help. The radar chart, Figure 1, architecture diagram, Figure 2. Those training pipeline diagrams, Figures 3, 4, 5. They make the complex parts much easier to grasp. The abstract is also concise and effective.
Agreed. Now, methodology. This feels like a major strength, right? The sheer scale, over 600 billion tokens, but more importantly, the meticulousness of the dataset construction, the video focus, the quality control, the recaptioning. It's impressive data engineering.
Absolutely. And the training innovations, too. That 5-mode cold start for reasoning using RL for fine-tuning. These are compelling advances. And crucially, that rigorous data decontamination strategy, using FASH, MinHash, CLIP similarity to prevent benchmark leakage. That commitment to fair evaluation is a huge methodological plus. Plus, developing and open sourcing KCM bench is a significant contribution in itself, filling that real-world short video gap. And the human evil protocol is well described and robust.
They do mention one limitation themselves, which is commendable transparency. Using another MLLM as the reward model in RL, they admit it has issues with reliability and computational cost. That's an honest assessment of a current challenge.
Yeah, good point. So contribution and significance. Overall, I think Kwai Keye-VL is a really substantial step forward for MLLMs, specifically in this tricky domain of short video understanding. It feels significant.
I agree. The innovation is clear. That multi-stage training, the nuanced reasoning training, Cold start, mixed mode RL, iterative alignment, and especially that auto think mode where it decides when to reason. That feels like it's genuinely pushing the boundaries, teaching the AI how to think efficiently, not just process more data.
And the open sourcing of KCMM Bench is a great resource for the community. Plus, the practical impact better user experience confirmed by humans focus on commercial uses for platforms like Kwai. It underscores the real-world relevance.
Okay, what about potential biases? It's industry research, though. The reliance on proprietary in-house Kwai data is one thing. While totally relevant for their goal, it means others can't replicate the exact training environment because that data isn't public. Common issue, but worth noting.
Right. And similarly, the internal benchmarks, KCM Bench, the human evil setup, were developed internally. Even with the best intentions, there could be some unconscious bias towards tasks or metrics where their model naturally does well. But as you said, their strong performance on standard public benchmarks helps balance that out, providing external validation.
Fair point. Lastly, gaps and unanswered questions. What limitations did we see, or did the authors point out? They mentioned the video encoder architecture and encoding strategies weren't specifically optimized yet. Suggests there's still potential to squeeze out even more performance there.
Definitely an area for future work. They also candidly state modest advantages in perceptual capabilities and that the think with image stuff is still preliminary, maybe not quite at the level of something like OpenAI's O3. So finer-grained visual understanding and more advanced tool use are still frontiers.
And that reward modeling issue in RL we mentioned. Finding better, more reliable, and cheaper ways to generate those reward signals is a key research challenge.
Yeah. And looking beyond the paper, you wonder, how does this scale to even bigger models? And what are the real-world computational costs of running these complex multimode reasoning processes in production? Those are big open questions.
So, wrapping up, Keye-VL really does feel like a significant leap for multimodal AI, especially for handling the complex, fast-paced world of short video. It's not just about seeing and understanding in a basic way, but about learning how to think appropriately for the task. That meta-reasoning, the auto-think mode, is really the standout feature for me.
I agree. Developing models that can autonomously pick their reasoning strategy combined with this deep grasp of dynamic video.
Yeah.
It has huge implications. Content recommendation, e-commerce within videos, real-time interaction on these platforms. It enables much more intelligent agents.
Which leads to a final thought, maybe. As these MLLMs get so much better at dynamic reasoning and complex tasks, how do we keep designing benchmarks that truly measure real-world intelligence? How do we avoid them just overthinking simple problems, or worse, just gaming the tests? It's a constant challenge. What aspects of Keye-VL stood out most to you listening? We're definitely excited to see where this kind of work takes AI in the video era.